Deep inside Death Valley National Park, California, lies one of the most hostile, extreme, and isolated landscapes on North American soil, a parched desert basin known as Racetrack Playa. Surrounded by the towering, stark peaks of the Last Chance Range and the Cottonwood Mountains, this ancient dry lakebed stretches for nearly 3 miles under a relentless desert sun. The floor of the playa is composed of fine-grained clay and silt, baked solid into a mosaic of hard mud tiles by extreme temperatures that regularly soar past 120 degrees Fahrenheit during the scorching summer months. Yet scattered across this barren, apparently lifeless expanse are massive stones, some weighing over 700 pounds, that seem to defy the most fundamental laws of classical physics. Behind these heavy dolomite and limestone boulders stretch long, prominent furrows carved directly into the sun-baked mud. Some of these tracks extend in remarkably straight lines for hundreds of yards across the flat playa floor. Others bend sharply at right angles, form graceful sweeping curves, or loop back on themselves in eerie, erratic zigzags. For over a century, prospectors, park rangers, and geologists who stumbled upon Racetrack Playa were left completely bewildered. No human footprints, animal tracks, or heavy machinery marks surround the boulders. Nothing appears to touch them except the whispering desert wind. Yet the rocks have clearly traveled great distances, leaving unmistakable trenches behind them. How can stones weighing hundreds of pounds move across a bone-dry, flat desert lakebed without any human or animal intervention? Why had no human eye ever witnessed a single rock in motion despite over a century of continuous human presence in the region? What secret mechanical force governs the famous sailing stones of Death Valley? To comprehend the enigma of the sailing stones, one must first explore the unique geographical and geological setting of Racetrack Playa. Situated nearly 4,000 feet above sea level in a remote high desert basin, the playa receives less than 2 inches of total rainfall in an average year. The surrounding mountains are composed primarily of dark dolomite belonging to the ancient Bonanza King Formation, created over 500 million years ago during the Cambrian period. Over millennia, massive blocks of this heavy stone fracture off the steep cliffs of Racetrack Peak and tumble down onto the playa margin below. During the summer months, the heat in Death Valley is suffocating, evaporating every trace of moisture and baking the clay mud crust into an impenetrable concrete hard floor. But during the winter months, the climate transforms dramatically into a frigid, wind-swept wilderness where nighttime temperatures regularly plunge well below freezing and mountain runoff occasionally drains into the dry basin, forming an ephemeral pool of water. The mystery first gained formal scientific attention in the early 20th century. In 1948, geologists Jim McAllister and Alan Agnew published the first preliminary report on the sliding rocks, noting that heavy dolomite boulders from the nearby cliff face of Racetrack Peak had traveled hundreds of feet across the playa floor. Over the following decades, researchers began meticulously mapping and tracking individual stones. In 1972, geologist Bob Sharp of Caltech and Dwight Carey initiated a long-term scientific study, naming 35 rocks and placing wooden stakes around them to monitor their movement over 7 consecutive years. During their study, Sharp and Carey documented astounding and perplexing patterns. Some tracks ran side by side in perfect parallel alignment for over 50 yards, as if 2 massive stones were locked together in a synchronized ballet, before suddenly veering off in completely opposite directions. Other trails ended abruptly, with the rock sitting silently at the terminus, while some trails were found completely empty, their rocks nowhere in sight, having apparently disappeared or been removed by visitors over time. Heavy dolomite boulders fallen from the surrounding cliffs left deep, wide trenches in the clay. Smaller, lighter stones created shallow, winding trails that snaked across the playa floor. Because the movement was never seen in action by any observer, wild speculation quickly filled the scientific vacuum. Local legends spoke of mysterious magnetic anomalies pulling iron-rich rocks across the basin floor. Others suggested anti-gravity phenomena, subterranean acoustic vibrations, subtle seismic shifts, or even extraterrestrial intervention. In the mid-20th century, serious atmospheric scientists set out to solve the puzzle, convinced that basic fluid dynamics and meteorological physics would quickly expose the truth. But every initial hypothesis collapsed under rigorous testing. Early researchers proposed that hurricane force winds during violent desert winter storms were pushing the massive boulders across the playa. However, wind tunnel experiments and aerodynamic calculations quickly disproved this explanation. To push a 700-pound Dolomite rock across dry or slightly damp clay, winds would need to reach speeds exceeding 280 miles per hour, velocities far beyond anything ever recorded in Death Valley or anywhere else on Earth's surface. Another popular hypothesis claimed that dust devils, intense localized whirlwinds common in desert environments, were lifting and propelling the stones. But dust devils are chaotic, spinning vortices that move erratically across the landscape. They could never create perfectly straight, parallel tracks that extend for hundreds of meters across a flat surface, nor could they move multiple rocks in identical directions simultaneously. Researchers then turned to magnetism, bringing sensitive magnetometers to Racetrack Playa to test the physical properties of the boulders. The results were conclusive. The Dolomite and limestone rocks were completely non-magnetic and contained no unusual iron minerals that could interact with Earth's geomagnetic field. For over 60 years, science remained completely stumped. Death Valley's moving rocks stood as one of geology's most frustrating, mysterious, and haunting unsolved natural enigmas. The ultimate scientific breakthrough finally came when paleobiologist Richard Norris of the Scripps Institution of Oceanography and his cousin, engineer James Norris, decided to take a radical and unprecedented approach. In 2011, they founded the Racetrack Playa Slithering Rocks Project. With official permission from the National Park Service, they custom-built 15 GPS trackers and embedded them inside real Dolomite rocks that were placed on the playa floor. They also installed a solar-powered high-resolution weather station directly on the playa to continuously record ambient temperature, wind speed, solar radiation, and soil moisture. For 2 long years, the Norris team waited patiently. They made periodic trips to Death Valley, checking battery levels, downloading sensor data, and inspecting the stones. For over 700 consecutive days, absolutely nothing happened. The rocks lay completely motionless under the burning sun and freezing night air, as if stubbornly refusing to cooperate with modern scientific inquiry. Then in December 2013, an extraordinary and incredibly rare sequence of atmospheric conditions converged on Racetrack Playa. A winter storm swept across the desert, dumping a rare deluge of rainfall that created a shallow pond across the southern end of the playa, measuring just 3 inches deep. Shortly after the storm passed, a severe Arctic cold front swept through the valley, plunging nighttime temperatures down to 22 degrees Fahrenheit. The shallow pool of water froze solid overnight, forming a wafer-thin sheet of ice across the playa's surface, a delicate phenomenon known as window pane ice, measuring only 3 to 6 millimeters thick. On the morning of December 20, 2013, Richard and James Norris arrived at Racetrack Playa to check their instruments and witnessed history in the making. As the morning sun rose over the surrounding mountain ridges, its heat began to crack and thaw the ultra-thin ice layer, breaking it into massive floating panels dozens of meters wide. Around mid-morning, a gentle breeze began to blow across the playa, reaching speeds of only 8 to 10 miles per hour. As the wind blew, the massive sheets of thin window pane ice began to slide across the shallow surface water. Though the ice sheets were paper-thin, their colossal surface area allowed them to capture the light wind like a giant sail. As these floating ice panels moved forward across the water, they pushed against the submerged bases of the heavy stones resting on the lakebed floor. Slicked by the shallow water and resting on a thin layer of soft, saturated mud slurry, the friction between the heavy rocks and the ground was dramatically reduced. The moving ice sheets propelled the multi-hundred-pound boulders slowly forward at a pace of just 2 to 5 meters per minute. The researchers stood in absolute amazement as dozens of stones moved simultaneously across the playa, leaving fresh furrows in the soft mud beneath the shallow water. Detailed hydrodynamic analysis later proved that large ice sheets spanning thousands of square feet can generate enormous mechanical pushing force even in faint breezes. The GPS units recorded exact movements, revealing that stones traveled up to 224 meters in single moving events, sliding continuously for up to 16 minutes before coming to a complete rest. Days later, as the desert heat returned, the shallow pond evaporated completely under the sun. The thin sheets of ice melted into thin air without a trace, leaving behind no physical evidence except for the freshly carved tracks in the drying clay. When the mud hardened under the blazing sun, it preserved the new trails, creating the exact same mysterious scene that had baffled scientists for over a century. The landmark study, published in the peer-reviewed scientific journal PLOS ONE in August 2014, revealed why the sailing stones were so rarely witnessed by humans. Their movement requires a fleeting, highly specific alignment of 5 distinct environmental conditions. First, the dry playa basin must fill with just enough water to submerge the rock bases without covering them entirely. Second, nighttime temperatures must fall low enough to form thin windowpane ice. Third, the ice must be thin enough to break and float, yet strong enough to push the heavy stones. Fourth, the morning sun must thaw the ice into floating panels. Fifth, a steady, gentle breeze must blow across the lakebed while the mud floor remains soft and saturated. If any single one of these 5 environmental variables fails to occur in precise sequence, the rocks remain completely frozen in place. If the ice sheet is too thick, it freezes the rocks solid into the mud floor. If the water pool is too deep, the ice floats harmlessly over the top of the stones without touching them. If the morning sun is too intense, the ice thaws completely before the wind can move it. Returning to the silent, timeless expanse of Racetrack Playa, those massive Dolomite boulders scattered across the ancient lakebed were never moved by supernatural forces, magnetic anomalies, or raging hurricane winds. They were propelled by the delicate, almost invisible mechanics of melting windowpane ice and gentle desert breezes. Rather than robbing the desert of its magic, science revealed a natural choreography far more elegant than any supernatural myth. Nature's grandest and most baffling mysteries often hide behind the quietest, most subtle forces in the natural world. What other extraordinary secrets are waiting in Earth's forgotten corners, waiting for someone patient enough to look?